So, the previous speakers talked about high tunnels and soil health, so on and so forth. So we're going to switch gears and talk about weeds, as in weed management. So I've been the extension specialist, fielding calls from growers throughout the states in different commodities for the past 18 years or so. But around 2010 or so, about 8 years or so ago, I've been getting more and more calls on this invasive plant called jointhead Arthraxon, or it's also referred to as carpetgrass or jointhead grass. It's a non-native invasive species that was introduced from the Orient. I think it has been in the US since the early part of the 20th century. But it's supposed to have been more prevalent in the southern states, and it seemed to have moved northward to a point where, as I mentioned earlier, it started to show up in some of our pastures, cool season grasses, in the late about 8-10 years or so ago. It's considered to be unpalatable to livestock. So if you have a field that is invaded by this weed, it just stays there, and basically that pasture is rendered unproductive. So this is a photo sent by one of the county agents in the southern part of the state, Putnam County. As you can see, this field was basically taken over by this invasive grass, and there's nothing basic. It's waste of resources there. Close-up of how this weed looks like. It looks somewhat similar to a plant called deer tongue grass. Anybody of you familiar with that grass, deer tongue grass? Good. So it's slightly shorter, grows about ankle height. That's how tall it grows. Broader leaves, and if you look at the base of the leaves, there are a few hairs right there, a small fringe of hairs. And also it pulls off easily at the nodes. So that's the reason why it's called a jointhead grass. So this is a picture of the deer tongue grass. It's much more stouter and sturdier and taller than jointhead grass. The primary objective of this study was to look at options for controlling this weed, which was otherwise which was very difficult to get rid of. Now a secondary objective became how to determine the germination of this weed based on a degree model. For that, we had two experiments that was carried out in 2016 and 17 under cool season pastures, which had a history of this weed for the past 3 to 5 years or so. The native forages were the cool season grasses, including tall fescue, Kentucky bluegrass, and orchard grass, and a mixture of clovers. It's typically the kind of pastures that you see, in the Appalachian states. So as you know, the degree day model is based on a base temperature of 50 degrees Fahrenheit. So as you know, it's calculated by subtracting the base temperature from the mean temperature of the day, and taking a cumulative value of the respective growing degree days from the beginning of the Julian calendar, and you accumulate that to a certain value, and try to correspond that to these phenological attributes such as germination of weeds or flowering of plants, etc. In 2016, we had roughly 207 growing degree days by April 25th. Okay. Now, based on the historical average, I think it was for the past 100 years of average, that was achieved. The 207 growing degree days was achieved only around May 22nd. So you can see that we are almost a little over a month ahead of the typical times when the 200 or 207 growing degree days has accumulated. Now in 2017, it occurred around April 18th. So again, it's the same trend. So this was the first year, and I was not able to go before these weeds germinated to take a picture, But this is probably just about 2 or 3 days after this weed germinated. And this was on April 25th, when the growing degree day had accumulated to 207. Now, the following year, that is 2017, I was able to go back to the field to see if these weeds germinated. And on April 12th, when the growing degree days was 157, this particular spot, this field was infested with this weed the previous year. So I was pretty sure that any bare spot would serve as a good indicator of where it would germinate. So in this particular case, this spot did not have any weeds on that day. That is April 12th. About 6 days later, when the growing degree days had accumulated to 217, you can see the same spot had weeds germinated. So this was just about 1 or 2 days since those weeds germinated. So based on this, we pretty much figured out that somewhere around the time when the growing degree days accumulates about 200, roughly 200 or so, that's when these weeds germinate. And this holds good for the time of the year when smooth crabgrass germinates, in cool season grasses, turf. Now, large crabgrass takes a little longer it needs more degree days to germinate. And a lot of times the landscape, the folks who manage lawns apply the pre-emergence herbicide when the forsythias are in bloom. Okay, that's when the forsythias are in peak bloom. That's a good phenological indicator of this 200 degree growing day. So the rest of the talk, I'm going to discuss an experiment where we looked at the efficacy of a pre-emergence herbicide called pendimethalin, which is sold as prowl in pasture and as pendulum in the turf industry. So it's an effective annual grass herbicide, controls primarily annual grasses and also a few small seeded broadleaf weeds. So it was applied at 4 pounds per acre. We also had another treatment which included glyphosate, which is a non-selective post-emergence herbicide. So the reason to include that was to make sure that during that year, by the time when we applied the pendimethalin, if there was any of the jointhead grass that was already germinated, make sure that they were all killed, and any subsequent germination was based on any subsequent germination that was inhibited would be from pendimethalin, the herbicide pendimethalin. So this photo was taken about 2 months after application of the herbicide. So you can see these were the treated plots. This had pendimethalin plus glyphosate, and this had just the pre-emergence herbicide. So all the surrounding areas where you see the light green color is due to the weed jointhead grass. Now you would wonder why, despite the fact that we applied Roundup or glyphosate that plot, why it's still lush green in color. That's because all the native species, all the tall fescues being a perennial, they came back. Okay, but you can see here in this plot, I don't know if you can see from there from the back, but you can see the tall fescue had already come to seed at that time. So it's further along compared to the glyphosate treatments. So this data set shows you the percent control that is obtained, and all you need to look at is the last column here. Basically, pendimethalin provided close to 10% control, excellent control of this weed. Glyphosate applied alone did not provide any control, which means that the pre-emergence herbicide was the reason for the level of control that was obtained. And this data set translates to the yield, the dry matter yield of this weed, which is reflective of percent control. So the dry matter tonnage per hectare was close to 0 in the herbicided plots and much higher in the untreated and the plots that received glyphosate. So this was how the field, the location where we had the study, how it looked in the month of October. Basically, the weeds had taken over. So when I first, this was, by the way, set up at a producer's farm. So when I entered the farm gate, I thought, he, from the sort of brown color, I thought he had applied, he got fed up and he applied, glyphosate or Roundup for the entire field to kill everything. But but this was due to the natural aging of the plant. When it sort of becomes dormant, it takes a brownish color. I don't know if you can see this clearly, but these were the plots that received a herbicide treatment, and all the surrounding areas which were untreated basically was taken over by the weed. And again, it shows that the pre-emergence herbicide, when it was applied, when the growing degree days accumulated to 200, provided good control. So that's all I had for you. Thank you.